break up the bingo conversation. Do you agree with first derivative of 2t plus 1 over 4? Okay. On Friday, you learned that to take the second derivative, you don't just take the derivative of the derivative. You take, I'm going to call this 1/2 t plus 1/4. You take the derivative of the derivative, but then you divide by dx dt, right? Now that's because of the chain rule. We talked about, I'm not going to show where that comes from every time. I would like you to understand that it comes from the chain rule, but for at some point you just have to know it's true. So the first derivative of the first derivative is just 1/2 divided by dx dt, which is 4. And you get 1/8 or 11. Okay. Number 15 and 16 I want to go over because your work stinks. Sorry, it's my fault. I must have taught you badly. So I will make clear you understand what I need to see. And just what good work consists of. So, at 16, what do you see that as? What do you see when you see 16?
2 times 1/3 n.
Okay, what kind of series is it? Say that. You need to say that. Okay, now I know that you don't know a lot of series, and you think, okay, they're geometric, all geometric. No, they're not all geometric. Very rarely are they geometric. It's just that's all that you know right now. Okay, so you need to start by saying, this is geometric. Period. Okay? When it's geometric, you go convergence, divergence a little differently. You look at what R is. The absolute value of R, not just R, is 1/3. You then show to the person reading it, you know the conditions for geometric to converge, which is less than 1. The test value must be communicated. You can't just say, it's 1/3, so it converges. Nope. It's 1/3, which is less than 1, therefore converges. You must communicate every one of those details before you try to find a sum. Because it converges, that's why I'm allowed to use this formula for the sum. A1 in this case being 2/3 over 1 minus 1/3, which is 1. Okay, that's what I expect to see. Say it's geometric, meet the conditions for geometric to converge, and then use the formula. Got it? Okay, the next one, is it geometric?
No.
It is not. What do you suspect it is? Telescoping. Okay, now I'm okay right now if you say, yes, it's telescoping, but I gotta say, don't think that just because you see a couple of fractions, factors, it's telescope, that's not necessarily true. For you, for now, it will probably be, but it won't always be. Okay? That said then, what's the approach if it's telescoping? We decompose it. 1 over n plus 3, n plus 4 equals a over n plus 3, b over n plus 4. Assuming you decompose that well, it decomposes to
1 over n plus 3.
1 over n plus 3
Minus 1 over n plus 4.
minus 1 over n plus 4. Now I told you these don't have to be telescoping. How you would see if it is or not is if you have a fraction minus a fraction, then it's got a good bet. But if it was plus and plus, you have no chance. There's no way it's telescoping if everything's positive. Okay. Don't worry, I won't throw you not telescoping one for a while until you start to get your feet under you a little bit. All right. After that, then, you do telescoping by trying to see what collapses or what the partial sum formula is. So what now should I do?
You list up.
Yeah, you have to take the limit, but what do you take the limit of? Not this.
Oh, you first figure out your SN equation.
Yeah. Okay. So that's the next. Actually, that reminds me. I should have talked about it over here. You need to understand the importance of labels in calculus. Okay. If you just say 1/3 is less than 1 with no label, that's meaningless. If you say S equals this when you really mean A, and A when you really mean S, Or even worse, you have no labels at all. That won't do. You must label. Terms are A, sums are S. Okay, I'll give you, because of the importance, I'm going to say in algebra, or in AB, they had a problem like this, and they found, the question was, part B was, where is it increasing and concave up, okay? I had a handful of people say, okay, well, let's see, I guess I need the first derivative, x minus 3, e to the x, plus e to the x. Boom. Okay, then the second derivative, okay, so derivative of that is x minus 3, e to the x, plus e to the x, plus e to the x. Cool. They did their sign test, they found the right region, 2 out of 3, because f prime was positive, or whatever it was, and second derivative negative. Guess how much this person gets out of 4? 0. None. Okay? The rubric says, find second derivative. Where's the second derivative? Okay? You need to understand, I have 200,000 exams right here for it. And I have a week to do it. I am in no way going to take some time to figure out, wonder what he's doing. Is this, do they mean that's the first derivative and that's the second derivative? No, it's going to be 0, 0. Done. Okay? If you don't make your work clear with notation, you are out. Out. So you need to work on communicating your work with labels. If it's the term, call it A. If it's the sum, call it S. Now, in this case, then, we want to create a formula for the partial sums. Some people, especially with experience, can just look at that and say, oh, the partial sum formula will be this. I can't do that. I need a little bit more to look at. So I might say when n equals 1 goes in, I get 1/4 minus 1/5 for the first term. When n of 2 goes in, I get 1/5 minus 1/6. And when n equals 3 goes in, I get 1/6 minus 1/7, and so on. You with me? Okay. Now, fight the temptation to add these. It does not help you to add these. In fact, it makes the problem harder. Do not add them. Say the first partial sum, not the first term, the first partial sum is 1/4 minus 1/5. The second partial sum would be these two. The fifths go away, and it's okay. Now you only need to continue this until you see the pattern. Now if you can see the pattern way earlier, great. If it takes you a little longer to say, okay, this time the fifths will go away and the sixths will go away, and I'll have 1/4 minus 1/7, and you start to say, okay, now I start to get it, great. The goal is to say the nth partial sum. If I ask, hey, what's the 50th partial sum? You should be able to give me a formula for whatever partial sum and tell me what the 50th partial sum is. In this case, what's the formula for any old partial sum? 1/4 minus 1 over n plus 4. Okay, your goal is to say what's always the same? Well, 1/4. And what is different tied to the index? It always seems to be 4 more, or 4 more, right? Okay. That means then if I want the infinite partial sum, then I want to say what happens to this formula as n goes forever. And that obviously would take the form of, because that second part would go to 0 as we get longer. Right? In terms of how I would grade this, I would say, did the person decompose it correctly? That's part 1. Did they create a formula? I would go straight for the formula. I don't care if you show me the terms. I don't care if you do. I don't care. Whatever it takes for you to see the formula, great. But I must see the partial sum formula, and then I must see the limit of the partial sum formula. And that's what I need to see. Okay? Understood? Good. Excellent. Yes, sir.
So, for the sums, where are you getting the 1/4 from?
When you look at the terms here, these, as you add more and more terms, you get a negative and a positive, and so you see that's why they call it telescoping, because it collapses on itself. But 1/4 never has anything to collapse with, so that's why it's always there. Okay? Question? Any other questions? Okay, cool. The lesson, the notes are kind of in a funky place. So if you get out your notes from set 115, they were several partial fraction lessons. And I put them all in the same note sheet. We did set 115 at the bottom of the front. It should say set 120 objective, something like that. Give you a second to find that. It's blue. Okay. If you don't have it, I just take it in your notes and stick it behind your set 115 notes. So, sorry, it should. This is what the bottom of that blue sheet should look like. Okay, it looks like this. The title of the sheet should be set 115, 120, 126, partial fraction decomposition. I'm at the bottom of the. Okay. I don't have extras. I apologize. I just assumed that you are so organized you would have them, but if it's in another notebook or whatever, like I said, do it later. Okay, so where I'm at. Okay, cool. Now, the problem of the day is that you've got this integration problem. It's fractions like before, but this is what makes it different. It's a little bit of a gotcha, and I like to imagine myself in, historical math. I'm a big dork that way, I guess. But if I were sitting around 300 years ago, and I had this problem, what would I have done? Okay. So you're learning this calculus, and you know you have to break it up, because otherwise you can't integrate. So you know you have to do something with it. How do I break it up? And I would imagine that the first logical thing would be to say, well, just do what I always do, which is write a numerator for each factor, like this. I mean, wouldn't that be logical? That's what we did before, just write a fraction for each one. Well, unfortunately, it just doesn't pan out. If you were to clean this up, it's 3 equals, you still have to multiply by the common denominator, so by the square to clear the fractions here. So a would be times x plus 3 squared, b times an x plus 2 and an x plus 3, and c times x. Did I make a mistake?
No.
Okay. X plus, gotcha. Sorry, thank you. X plus 2 and x plus 3. Cool? Yeah, you'll see a problem right away, because the minute you do a let x equal -3. You get 3 equals nothing, nothing, and nothing. You have 3 equals 0. Well, that's bad. Okay? You just broke math. So that is no good. I say wah wah. That does not work. So another logical assumption would be to say, well, forget the 3. Let's go with just 1 for the next one. Now this, I feel like, was a step forward. Forget that ABC stuff. I'll just do A for x plus 2 and B for x plus 3 all squared. Also pretty logical. Would you agree? Okay, so when you do that, you would get this kind of result. Now this one starts to feel like, yeah, this is working. When x is -3, I get 3 equals b times -1, so b is -3. And when I let x equal -2, I get 3 equals a. And so my theory is that this decomposes this way. You agree? Now, it would be wise, anytime you're coming up with your own math, you're setting new math, to check that it works, right? So how can I verify that's true? Yeah, I could add them together. If you add, it should be that, if I did this correctly. So I get 3 times x plus 3, quantity squared, minus 3 times x plus 2. That's something like, you can probably see it's not happening, x squared plus 6x plus 9 minus 3x minus 6. There's just no way. There's nothing to drop out there. The 3x squared doesn't drop out, and it's not going to be 3. Do you see that? 18 and everything else is definitely just wrong, wrong, wrong. It's just wrong on so many levels, right? So not equal. And at that point you say, doggone it, there's not dropping out like it should. So I need some kind of mixture between the two. I need this to drop out. I need this to come together so the x squareds drop out, but this didn't work. So to get more power and x squareds dropping out, some genius, and I don't know who, said, you know what, I'm going to make that square. And so with that, I might get a little x squared dropping out action in the numerator. Now that is the big idea we get. If you get a partial fraction decomposition where you have a power in the denominator, you have to do this kind of special technique where the first factor, you just use it like always. But the one that's got a power, instead of just straight up going to it, you build up to it. The second factor, you first go to the first, then to the second. That you'll find will work. Now that's if you square. If it's a cube, it's a little worse in that you still have a factor for the first, but the cube you must take to the first, second, and third, gradually building up. Yes?
Wait, so then is the second one supposed to be?
Oh, there's an error there. This is supposed to be 2.
Okay.
Thank you. Yes, typo. Make sure you change this. Okay? All right. So here's the process. This, as you can see, is the same problem that we were getting nowhere on. But now you'll see it'll work. 3 over x plus 2, x plus 3 quantity squared decomposes into what? A over x plus 2, b over x plus 3, c over x plus 3 squared. Okay, when there's a square present, then you have to gradually build up to that square, and that's the only thing that makes the numerator canceling happen so that we get something that cleanly through. So if I clear the fractions, I get 3 equals a times x plus 3 squared. You agree? B times x plus 2, x plus 3, and c times x plus 2 only. Now, there is one little extra wrinkle in here, so stick with me if you think you're home free. Not quite, we'll get there. The let idea still works to an extent. If I let x equal what? -3. Okay, if x equals -3, then I get 3 equals a drops out, b drops out, and c times -1, implying that c is -3. That seems fine. Let x equal -2. 3 equals a times 1, and the b and c drop out.
What do you do about B?
Good question. And that is the gotcha. So, do you agree that c equals -3 and a equals 3? All right. You do a little bit different technique for the b. Consider, to find b, if you distributed, now this I'm going to show you in a fairly long way, but pretty soon you'll be able to just do this mentally. You'll see, oh, b is -3. Okay, you'll see that in just a second. So the idea goes like this. If you were to distribute, then you could get a big mess. Now please understand, I don't want you to distribute. You have lives. You have lots of fun stuff to do, okay? So just consider, if you were to distribute, you would have some x squareds and some x's and some constants, right? Okay? How many x squareds would you have altogether? X squared, 2 x squared terms. I see what you're saying. What would the
A plus B.
a x squareds and b x squareds, right? So if I got those x squared together, I know that the total of those x squareds would be a and b. Now that's really all I need to do. Because I know that the x squared, if these two equations are equal, then every term should be the same. The number of x squareds on this side should equal the number of x squareds on that side. And the number of x's on this side should equal the number of x's on that side. Now you can see that I have no x squareds. That implies that a and b must be canceling each other out. if I have no x squareds over there. And therefore, a plus b must equal 0, which means then that b must be the opposite of a, and therefore, negative 4.
Oh, it's more easy than how Canon taught us.
It should be distributed. Yeah. I'm lazy, and you get a benefit from that. Okay, laziness wins, always. Actually, it's no, whatever. You get a benefit from my laziness. That's the best. Yeah, that's actually terrible advice. You guys said that. Okay, laziness loses every time. All right. Now, my decomposition then, there's still one little gotcha in here. The integration has one little mistake place. So let's continue on. Normally I'd say integration, no big deal, but I just want to review. So my decomposition is a over x plus 2, and I found a to be 3. Okay, so I have 3 over x plus 2. Obviously that will not be any issue to integrate. B is over x plus 3, and so that means negative 3 over x plus 3. That also will not be an issue to integrate. C was negative 3. This is the part that people tend to make a mistake on, so that's why I'm continuing on. The first antiderivative, big deal. The next is negative 3 natural log of x plus 3, that's fine. Natural log on that last one? No, that's power rule. Okay, don't, obviously that's a pretty rookie mistake to think anytime you see a fraction it's natural log. That's not true. It's only if it's to the first that it's natural log. Think negative 3, 1 over u, or negative 3 u to the negative 2. Sorry. What's the antiderivative of negative 3 u to the negative 2? Positive power rule? Positive 3 u to the negative 1, right? When we integrate power rule, we raise it by 1 and divide by the new power. Remember? Okay, so this should raise to negative 1 and divide by negative 1, giving us plus 3. Oops. Plus 3 u to the negative 1. Now, I don't need to see this up inside. That's just what's going on in my head. Plus 3, 1 over x plus 3. I guess I could have written that better, but you understand. Plus c. You follow? Okay. Rather than do this one, let's do 5 on the homework. Number 5 does not take much to please you. Number 5 on the homework is this. That one. That has that idea, the idea being that you have a square in the denominator. Okay, try that. Let's see how it goes. Oh, I have an extra. Do you want it?
No, it's okay.
It's going to be another lesson.
Yeah, I'll just copy it. I already copied it. Okay. Oh, wait.
Really the only I want to do like the
Oh, that's good, yeah.
it's just 4 times equals 2. How does D, how does the canceling of D make a negative? Oh my gosh. Okay. I just saw that online. It made me laugh. It's so awful. Yeah. Everyone's always like, how does the negative like it's the fraction? You should make that my home screen. So now that kind of student. You should put that on every single one. It's all. Oh, I just heard you wrote it down because you thought it was awesome. All right. Sounds good.
Did this go okay, or should we go over it? Go over it? Or no, fine, no problem. Talk to me, people. You're good? Thank you, sir. You folks, so what?
Oh, wait, is this in the back foot?
Yeah.
Yeah.
5? Anybody not get the answer on 5? So go, just move on? Okay, cool. All right. That's, we already talked about that. Questions on 119? Oh!
Oh my goodness.
Oh my goodness. Oh no, we're turning it in. Number 2. Do you have a question on number 2? I had a lot of people miss number 2 on the homework. Okay, number 2, it's because they gave you acceleration and they asked for average velocity on 1 to pi or 0 to pi. Can I do this? Yeah. Okay, so if you had a problem on 2, it's probably because you thought you could just do that. That's for the average acceleration. This is the acceleration, not the velocity. So you need to first integrate to get velocity, then do that on your velocity. So you're actually going to have to integrate twice. Okay? On number 20, or the last one, did you get maybe max y is 33.104? This is the last
Oh, I
question.
actually go with that stuff.
Okay, did you get the hits the ground at 2.3 or 3.3345?
Yes.
Unfortunately. For a total distance, it's the same as the arc length in parametric,
I
25.425.
think it is a 9. I think that's a 9 instead of a 5 in the part B.
This is a 9.
Yeah. Yeah, that's what I got as well.
So actually, this might be wrong based on how long it was in the air. You have something different for C.
I've got 39.457.
So the arc length is roughly 39-ish?
Yeah.
Point what?
457.
456?
457.
7. Okay. And dy dx, that also will probably change because she had the time wrong as which it hit the ground. So you would need to do dy dx to find the slope at the moment it hits the ground. That's when it hits the ground. Find the slope. Then you'd have to do the inverse tangent of that slope to find the angle that slope makes with the ground. And so that is some answer I don't have. Do you have it? Is that what you did? Go ahead.
No, I
That
just
right?
did.
Okay. All right. This is due by the end of the day. As long as you gave it a good go, we're good. I'll be happy to go over questions tomorrow when I get them back. Get them back. Let me know if you are sticking around and you want me to go over something.
Mr. Raymond, I have a couple of questions.
Yes, ma'am. Sir.
Whoa, sir, that was like, not bad. So, oh, yes. Well, you
Thank you. Okay, so I took my brother to drama, and then I have a tutor. So how long is everyone gonna be here? A while.
You work as one of the class. This is little before I put fractions, so really. I'm pretty sure.
So like on this, so
it starts as A over x plus 2, B over x plus 2. When I clear the fractions, that's when like get rid of the denominators. I'm going from here to here by multiplying by the common denominator.
Let me do that really fast.
Probably true. On both sides. Now it's mathematically allowed because I'm multiplying both sides by it. When I do that, the x plus 2 drops, make it be x plus 3 squared. When I go here, and x plus 2 drops. I'm sorry, NX, see what I'm saying here?
yeah, I see what you're saying. I guess what I use, my other thought process is like before we learn this stuff, I would just multiply this by anything other. Yeah.
That's maybe a bit of a...
But that is like kind of a
It's true,
shortcut,
it
but-
is true, but you need to know where.
Yeah, that makes sense.
Because it's like on a graph.
And then,
Like just because.
and my other question is, since I was taking the test on Friday, do I have to turn it in today?
You can. Okay, just make sure you're taking tests.
I'll turn in 117, 116, 118 today.
Sounds good.
Well, I told them, I know, I literally, they're trying to make me start writing every 400s, every 600s, every